Hey there.
It's it's connecting from Zoom to YouTube now, so
All right. Waiting for the technology to kick in.
yeah, now we are live.
Perfect.
All right. So hi everyone. I'm very excited for this session, and I'm fortunate to find and met Sergey in AC Tech Hackathon because I have done 2 hackathons with him, and it has been amazing experience. He's very passionate in each of the project he did. So I reached out to him, and I shared it would be good if we can do a hands-on and live plugin workshop session, and he was very kind to do it. So I'm really thankful, Sergey, for your time to do this.
Well, thank you for having me. I'm very excited to chat with you this morning. So this
Yeah.
is very exciting for me as well.
Mhm. He's a application developer at Thornton Tomasati Core Studio, and he has worked on various projects. And I during the end of the session we'll have a bit of informal chat about his work and lifestyle and his experience from computational design to software development. So I think without much ado, we have a lot of content to cover, so I'll hand over the stage and virtual stage to you, Sergey.
Thank you. Yeah, so we're gonna have to move rather quickly. Just to kind of very briefly give people an idea of, you introduced me a little bit. But yeah, I'm a software developer. I kind of started off as an architect. I went to architecture school. I graduated from Pratt in 2017. And then I worked in the industry for a little bit and then got picked up by TT, and my life has never been the same. So today what we're gonna do is we're gonna take a look at Rhino plugin development, but also a very specific part of WPF UI development that has to do with MVVM. What is MVVM? So MVVM stands for Model View Viewmodel, and it's essentially a design pattern that a lot of modern applications follow, which basically serves to decouple the user interface from the business logic of the application. And the reason why MVVM is very important is because, well, first of all, it's kind of an industry standard for a lot of applications. It's also quite a bit different from the way normal WPF applications are built. And I think it's just good to look at MVVM specifically in the context of Rhino plugin development, because Rhino encourages the use of the MVVM pattern whenever you build stuff for Rhino as a developer. So let's jump in. You guys are free to follow along. The only thing you'll really need, aside from Rhino, which I imagine if you're part of this crowd, you probably have, is Visual Studio 2019. If you have an earlier version of Visual Studio, that's not a problem right now. It might be a problem a little bit later on. But anyway, let's jump in. So I want to show you one thing first. So just as an example of what are the things that you can build using this pattern is a plugin that I put together last weekend, just kind of as a sample project. And you will able to find it on GitHub. So we posted some links in the chat. So there's a link to a plugin, a GitHub page called Space Monkey. And I'll demonstrate in a second what exactly it does. Okay, so Rhino is starting up, and my laptop is struggling a little bit to keep up with both the screen sharing and the video. So I might turn off my video, if that's okay. Or maybe we'll just leave it as is. All right. But yeah, while this is starting up, if you guys want to go ahead and click on the link and check out the repo. It's open source. You can install it, download it, mess with it, fork it, do whatever you want. But there are also pretty detailed installation instructions if you actually want to play around with this. So let's see. Yeah, this might be a little bit painful. All right. Usually,
you have a lot of background programs running.
No. So what happens is when I try to share my screen, my laptop is struggling both rendering stuff to my screen and also like live sharing to Zoom. So that's usually the case. But it's okay. We made it through. So okay. So here's our very simple plugin. We have some settings here. So this is a dockable panel, right? So we can undock it and dock it back in. And what it does is it calls into an API to get a set of satellites orbiting Earth at this point above, at this point in time above a certain point on Earth's surface, right? So I can determine what latitude and longitude and even altitude I want. I want to create let's do a 90-degree search radius, all satellite categories, and we're going to click search. And so it's going to call the API, and now we got some results back. So we're rendering only a section of the results at a time because otherwise it's just a little heavy for the computer to render everything at once. But here's basically everything that's flying above the coordinates that we specified. We can look at each individual satellite, see some metadata, and most importantly, we can bake all this stuff to Rhino. So if you're wondering how much space junk is out there right now, well, that's how much. And just in case you're curious, it's like, well, Sergey, we're all part of the AC crowd, or most of us, so why are we tracking satellites? I guess this is just, first of all, I'm a space nerd, and this is kind of just an example of the things that you can do with Rhino. But yeah, so essentially, we're able to call an API, get the response back, display it as part of our UI framework inside of Rhino, and also convert it to actual Rhino geometry and bake stuff out. And let's see, we can actually see the attributes of objects here. So if you go to properties and you click on attribute text, you can actually see all of this stuff baked into Rhino. And this is very useful, when you're not tracking satellites, but when you're actually doing some building projects. If you need some sort of a persistence when you go from Rhino, or say from Grasshopper or a Rhino plugin to the document, but then you want to read information back out, let's say from Grasshopper, it's really handy to be able to save and bake some metadata into the geometry, because then you can recover it when you load it back up. And not that this is important for this particular discussion, but if you're wondering how all these satellites can be so close, well, if we look at the altitude, like this guy's is pretty close, but it's still, the altitude is 1,100 kilometers above the Kármán line. So we're very well into space. Space is big. So anyway, this is the app, right? So this is what we not trying to build right now, because that took about that took the whole Saturday. So we're not going to try to follow along actually building this application. But this is just kind of to get you guys excited about the possibilities of what you can build in Rhino. And this kind of brings us to the discussion of MVVM and Rhino plugin development. So, okay, there is that.
Sergey, just to clarify, that attribute and model viewing makes it a MVVM design pattern, because like one can also call API render points and define those functions locally. So what aspect of the whole procedure makes it MVVM?
Yeah, so we're going to get to this in a second. There are a lot of components here, right? So we're going to try to keep things as clear as we can. But there's the Rhino plugin, right? That can be anything. It can be just a command without any UI that runs in Rhino. There is the UI portion that follows the MVVM pattern, separating the business logic of the application from the UI logic of the application. And we'll see this in action very shortly, right? Then there's material design, which is just a styling. Like if you look at how everything looks here, it's not your custom, it's not your standard WPF look, right? Like the buttons look different and the icons, well, there are icons. So everything looks a little different, right? The expanders and so forth. So that's kind of another layer on top of all of this. And then there's also an API layer when we're actually communicating with an external source, right? And we're calling into APIs. And that's another component of this. So a lot of moving parts. And I think your question is a great segue to actually trying to look very closely at what MVVM actually is and how to build an MVVM application. So for those of you who are actually following along, let's start up Visual Studio, and we're just going to create a new project, and we're going to go from there. All right, Visual Studio is starting a lot faster than Rhino, and in this case. So I'm going to create a new project, and let's call it something simple. Come on. Yes, everything is going to run a lot slower with Zoom, but that's okay. All right, so it's going to be a class library, .NET framework. And let's hit next, and we're just going to call it, I don't know, sample. Not very descriptive. And all right, I'm gonna call the project sample.mvvm, and then the solution name is just going to be sample. .NET Framework 4.8. Just creating it in default location doesn't really matter. So, all right, creating a new Visual Studio project. And I'm sure all of you guys are aware of what Visual Studio is, but if you're not, it's an IDE, which stands for an Integrated Development Environment. And that's basically a standard sort of industry standard IDE for .NET development. Okay, so here we have our new project. I'm gonna delete this, don't need it. So, okay, so let's take a look at how we normally design a WPF application, right? So if you right click here, and I'm just gonna create the user control. So add new item, and okay, WPF. Let's make sure that, yeah, user control. I'm gonna delete this, so I'm gonna just name it whatever. And in a moment, all right. So here's our designer. Here's our control, right? Well, coming up. So normally the WPF control consists of a XAML file. So that's your actual markup, right? So this is where everything lives in terms of like the graphical description of your UI, right? And then there's a code behind. And in the code behind is traditionally is where all of the business logic resides, right? So for instance, if I go here and if I say, I don't know, I'm just going to create a button here. Button. And I'm going to give it a name. I'm going to say my button. And then in order to be able to actually interact with it, if I say click and new event handler, I'm creating an event handler. So for me, automatically on the code behind side, it created an event handler, my button click, right? So this is traditionally how you build WPF applications. So all of the business logic that describes how the button reacts kind of resides inside this method, and that method is being called when we actually press the button. Now, what this means is that everything in our application, if we build it this way, all the business logic is very much tied to the UI, which is problematic for a number of reasons. So first of all, a little far-fetched, but let's just say we built an application, and well, .NET Framework doesn't run on Mac OS, but let's say we built our application in .NET Core. So .NET Core runs on Mac. WPF as the front-end framework very much does not. So if we wanted to port, for instance, our application from Windows to Mac, we need a different UI framework. But the trouble is that all of our code lives inside of the code behind of those UI components. So you can't just rip it out. You basically have to rewrite your application because everything is so tightly coupled, right? Another trouble is that you can't run your application, just your business logic, without the UI. Now, why would you want to do that potentially? Well, a number of reasons. One is unit testing. So unit testing is a great way to, well, write tests for your application and test individual components. And Visual Studio provides really great tools for performing unit tests, right? And the idea is that you write a bunch of those tests. Every time you make a change, every time you merge in the pull requests on GitHub, you can run your unit tests in Visual Studio or wherever, Jenkins, wherever you set that up, right? And if everything passes, all the tests pass, then at least you have some degree of confidence that whatever changes you introduce to your project, that those changes didn't break anything vital in your application, right? So this is just a nice way to quickly test a bunch of different components. Now, if your application is so tightly coupled to the UI, you're in trouble because you can't just call those, like it would be very hard for me to just call this my button click method, because it's a private method and it's an event handler, and it needs a sender, which is a button, which is the UI element. So chances are that it's probably possible, but it's going to be very, very, very difficult for me to write unit tests for such an application, right? So this is another thing that MVVM is going to help us with. Basically, by decoupling the UI from the business logic, it will allow us to just use the business logic on its own. So the view model doesn't know anything about the view. That's kind of the whole premise of this, right? The view binds to the view model, so it knows everything about the view model. And finally, we had some cases, for instance, at Core with some of our applications, which we're transitioned to this new MVVM approach, but with some of our older applications, for instance, we had some uploaders that required the UI to kind of sign in and confirm certain things. And then when we tried to run like a batch export in Grasshopper, right? So we're trying to send like 1,000 iterations. That became a problem because that component, it brings up a UI. So you don't want to have a human sitting there clicking the same 3 buttons 1,000 times each time the solution solves, right? And we couldn't just rewrite this. You basically want to pass all the credentials or all the options inside Grasshopper, so you have to write a new component, but you can't because, again, all the code is so tightly coupled together. So this is why MVVM kind of came to prominence as a pattern. And again, it's a pattern. It's not a software, it's not a plugin, it's not a library, it's just a convention, right, of how we do things through bindings. So, okay, so I'm going to delete this, and I'm going to create a couple new projects. just empty projects. They're all going to be class libraries, or 2 of them at least. And then we're going to see why and how we need them, right? So class library, .NET Framework. So I'm going to create a new project called sample.ui. And that's not going to be a WPF project, that's just a class library. So we're going to create that. Don't need that. And then we're going to create another project called also class library. And we're going to call this sample.viewmodels. We're going to create that. And lastly, we're going to create a console application just to run the entire thing. And then I'm just going to explain what are those things we're creating and why we need them. So if you look for .NET Framework, console app.NET Framework, and we'll call it something like sample.desktop. Okay, perfect. So what are those things? So sample.ui, we're going to have all of our views here, right? So we're going to make a bunch of, well, we're going to make one, but in theory, we would make a bunch of UI components that would live in the sample UI. Then sample view models, this is where our business logic is going to live. So this is the view models, which are Poco's plain old CLR objects. So these are just your C# classes, right? Very unassuming. Sample.mvvm, we're going to make a couple of base classes, which is just nice to keep them separate. So just they're reusable in case you have multiple different view libraries and multiple different view model projects. And then sample desktop, that's an application that will actually launch the thing, right? And I'm going to go ahead and go to properties, and I'm going to switch from a console application to Windows application so that we don't have a console popping up. So this is just going to run program the main method, and we'll be able to actually run it as an executable, right? So I'm going to set this as a startup project. Okay, so let's start with the view. So I'm going to create a new user control. This is going to be a window. When you're working with class library, I don't think Visual Studio allows you to create a window. There's probably a way around it, but we're going to create the user control and then turn it into a window. So let's just call it main view. All right, so we have our control here. And all right, let's give it some actual height. I don't know, 300, and width. Let's do, I don't know, 150, 200. It's going to be a small. It's going to be a small thing. And here, instead of user control, we're going to make it a window. So, okay, so let's do something here. Let's make a button or something. So actually, I'm going to make 2 things. Also, you're going to notice that I'm not touching the designer itself. So when I started out with WPF, I was using the designer a lot because you can actually like drop components and stretch them and dock them and whatever. What I discovered is that it's really hard to keep track of the way things nest and how things actually relate to each other, and what properties and margins are locked on what other property. It becomes a mess, right? So if you're working with the actual XAML markup, which is really nice, and it has italicence, and it's kind of like just writing C# code in a way, right? It just makes things a lot simpler. So my advice, if you're starting off with WPF, just don't touch the designer. Look at it, don't touch it, use the markup. So, okay. Let's make a stack panel here, and then I'm going to give it a margin for good measure. Let's make it an all-around margin of 10, and then I'll make two elements here. So I'm going to make a label, and actually, let's do, before we make a label, let's do stack panel vertical alignment center. So it is centered in our view. And then I'm going to create a label with vertical alignment top, horizontal alignment center. So it's going to try to float to the top and side of our stack panel here. And content, just going to write something here, right? So we got our label saying 10. And I'm going to make a button and call it, actually, I'm not going to call it anything, but it's going to have horizontal alignment center, vertical alignment top. The order of those properties doesn't matter. And then, yeah, for right now, it's just going to, oh, well, let's give it some content. So content, click me. Right. So, okay, a very simple WPF thing, right? We have a button and a label. Lucky us. So let's, because this is not a WPF app, right? We don't have like an app .cs. We don't have anything actually launching it, right? So sample desktop, we're going to go here and we're going to add a reference, a project reference to sample.ui. And this will allow us, so if we go to program.cs, we can say my main UI or my main window equals new, we called it main view. And I'm going to hit Alt-Shift to, wow, things are really slow with screen sharing. Okay, using sample UI. So Alt-Shift just lets you see your options in case of Visual Studio is highlighting something as an error. So new main view, and then we're going to do my main window. So we're not going to see italicence for this, but show dialog. And the reasons why we can see it is because we're going to be missing some WPF DLLs. So what is it complaining about? Oh, partial declaration. So what we did when we changed this to a window, we forgot to change in our code behind, we forgot to change this inheritance to window. That's why it's complaining. So if we go to program.cs, now it's going to be complaining about a different thing. Yeah, add reference to presentation framework. There's going to be a couple of those. Add reference to presentation core. And I think there's something else. Yeah, add reference to Windows base. We should be good. Okay, perfect. So now if you're wondering, it's like, wait, hold up. So you said that we don't have any UI dependencies in our kind of on our C# side of things. Like, why are we adding all of those WPF dependencies to this sample desktop, right? Well, this particularly doesn't really matter because this is just a thing that launches our entire application, right? This is literally all the code that's going to be here. If you have to replace that, that's not the worst tragedy. Also, it has to spawn our UI. So it needs to have all those dependencies, right? But that's literally all the business logic that's there. So, okay, cool. So we have our sample desktop here. If we go back to our main view, save this. This is set as a startup project. Again, right click, set a startup project, and let's run it. And hopefully it takes less than 20 minutes to actually show our little window here. But yeah, so we'll just see what we made. Also, for folks on the call, and Mayur, you as well, if you guys have any questions. Okay. Oh yes, calling thread must be STA. So another thing we forgot. This is just a WPF thing. So we have to put a decorator above main saying that this is an STA thread. Let's just not just do that. Let's just not worry about what that actually means. But yeah, if you guys have any questions, feel free to interrupt politely. Okay, so this is our thing, right? So we have our label, we have our button that does nothing right now. So how do we make this button do things, right? So because again, we said that, of course, we can bind to the click event or subscribe to the click event and create like an event handler, but we really don't want to do this, right? For all the numerous reasons that I described before. So what do we do? Well, in order to do this, we are going to have to create a little wrapper. So let's go to sample.mvvm and let's add a new file, and we're going to call it. This is just going to be a C# class, and we're going to call it a relay command. Cool. Make it public. So why do we need this? So let's jump back to the view model for a second. I know we're jumping around a little bit, but follow the bouncing ball. And let's create the view model for this application. So this is going to be where our actual business logic is going to live, right? So sample view models. Let's create another class called main view model or something. View. So we're going to create a public class main view model. So first off, before we get to the relay command, actually, let's very quickly take a look at bindings and how those work. So I'm going to create property here. So public int counter, and it's going to have a getter and a setter. That's very important for two-way bindings. You always have a getter and a setter, even if you don't need the setter. Just have it. You'll have issues. And then here, let's create a constructor for the main view model. And this counter, we're just going to assign it to, I don't know, 77, right? So, okay, so now we just have a C# object that has like a property that's set to a number. So how do we actually hook it up to the UI? Well, here what we're going to do, we're going to add a dependency from the UI to our view model, and that's fine. Again, the view has to know things about the UI, the view model, right? The view has to sort of understand the business logic, but that's also what makes the view disposable. So we can rip it off, put something else on it, it will still work. The view model knows nothing about the view. There's not going to be any dependencies from sample view model to sample UI. As far as sample view models are concerned, none of this exists, right? So in sample MVVM, sorry, in sample UI, let's go to the view and let's go to the code behind. So we're going to drop one line here. As I mentioned, like we're not putting any business logic in the code behind. but sometimes you're going to have to put like little things just to glue things together, right? And so we're going to say this data context equals new main view model. And we're also going to using sample view models. So if anyone with MVVM experience is watching this right now, they might be cringing me like, wait, what are you doing? Why are you just creating a new class and assigning it to data context? Because normally for applications like this, you would use some form of another development pattern called IOC, or inversion of control. And IOC kind of goes hand in hand with the dependency injection. And it's kind of the idea that the way you build applications should be very, like all the components of your application should be loosely coupled together through mostly interfaces, right? So you shouldn't have any dependencies on the actual implementations. You want to always have dependencies on just interfaces that can be implemented by multiple implementations. And what that allows you to do is it allows you to swap out components. It allows you to extend your application, injecting components into the mix, and instantiation of new classes in IOC happens through the architecture, not by the programmer themselves, right? So here we're not tackling IOC. Like this is just another dark forest that I encourage you to look into, because like MVVM and IOC are going to be two main search words for you if you're going to pursue development or like front end and back end .NET development. Also, in this SpaceMonkey GitHub page in the README, there are a bunch of links. If you look through the resource page, there's a link to a YouTube playlist by a person named Angel6, I suppose. And they have really great detailed tutorial on like how to set all of this up with IOC. They're using Ninject, I think, as their IOC framework. There's also Castle Windsor. There's a bunch to choose from, right? But you have all this material here. So we're just keeping things extremely simple. We're creating a new instance of main view model, and we're assigning it to data context. So data context is a property on all WPF controls, which is basically an object that the UI is going to look at to try and find bindings. So by assigning main view model to the data context, we're essentially exposing all of our public properties on our view model to the interface, right? So now we can bind to them. So what we can do is I'm just going to copy counter in case I manage to misspell it somehow. Always a good precaution. So in our label here, instead of content, so right now we set content 10, we're gonna say content binding counter. Now you'll notice that it disappeared, mostly because right now the designer doesn't really know, like it doesn't know what's happening with the view model. It has to compile the application and run it in order to be able to see what properties have what values. There is a way around it, because obviously it's not ideal to have like UI elements with no content in them. You can create design view models, which are basically view models that have value at the time of the design process, right? Again, let's not go deep into the woods right now. The tutorial that I linked to, they also explain all of that, how to set all that up. So we're just gonna remember that we have a label here and that it's gonna show some stuff, right? So let's see what kind of stuff it shows. So in our original UI, we assigned it to 10. We removed this with a binding. And in our main view model, if we take a look at that, we assign 77 to that UI, right? So now you can see that in our main view model, we assigned the counter to 77, and we can see 77 here. So that binding pulled the data from our view model. So that's great. Okay. Cool. So let's try to iterate this. So we created this relay command for a reason here. So let's create just a public void back in our view model. Public void. I don't know. Click button. Or actually, let's give it a better name. Let's call it public void count up. And it's not gonna take any inputs, and we're just gonna say this counter, add 1 to it, count up. So if we go to, like, how do we actually assign this to our button, right? Because this is in the view model here. We can't bind to methods, like that's not something that WPF does. We can bind to properties though. So what we need to do is we need to turn this method into a property. How do we do that, right? So if we go to our sample MVVM here, so we create this relay command, and we're going to inherit from an interface called iCommand, and this is just part of Windows input, right? And so this is going to complain that we are not implementing the interface. So let's go ahead and actually implement it. So what did we get here? So we got an event handler, can execute method, and then an execute method. So event handler, we don't really care. So we're just gonna give it like a default event handler. Oh, yeah. So it's just gonna do nothing when it's hit, right? Can execute, we're just gonna return true all the time. There's no conditions that need to be met for this to work, so we're just gonna be lazy here, right? And then execute. So let's create a constructor. So we're gonna say public relay command, and it's going to take an action, right? So what do we do with this action? Let's create a new property. So it's going to be a private action. And then in the constructor, when we instantiate the class of relay command and we're passing an action, we can actually assign it here. So my action. And when we're calling execute, we're just going to execute the action that we're storing. So we're just calling the action. So what had just happened, right? Essentially, we've created a class that binds from iCommand. When you instantiate this class, you pass it an action, and an action is essentially a method that doesn't take any inputs or doesn't produce any outputs. So it's no inputs and void as output. And we can store it as a private property. And whenever the execute is called, then we can actually perform that action, right? Now, what's going to be calling the execute method? Well, the UI is going to be calling the execute method because WPF controls know how to interact with the iCommand interface. That's why we're implementing this interface. So when the iCommand, when execute is called, WPF will basically call this method and we're going to perform our action. That's basically what's happening here, right? So let's go back here and let's create a public iCommand count up command. So right now we have a public property that, again, the WPF can bind to. But now we need to assign an action to it. So we're going to say this count up command equals new, and we need to add sample MVVM as a dependency here, reference sample.mvvm. Okay, so new relay command and we're going to pass our this.countup method here. And let's just set the counter to 0. So again, just to reiterate, right, to really drive this home. What's happening here? We're creating an iCommand property because this is what WPF can bind to. It knows how to bind to public properties, right? And we're assigning a class that implements this interface called relay command. Relay command can take an action. We're passing our count up method as an action here. So it's going to store it. Each time execute is called by the UI, this command is going to run. So we're not going to see the UI, the counter updating just yet. We're going to have to make some new steps. But I'm going to just set the breakpoint here. And if we run this, then we'll see it being hit, hopefully. So yeah, if you guys have any questions so far, let me know. All right, so again, we changed our assignment here. It read 0. So if I say click me, oh, it's not going to get hit because we forgot to bind it. And I say we just to disperse the responsibility because I forgot to bind to it. So okay, count up command. So in our view, we're going to, just like we did with the label, except here, not with content, but we're going to go and say command. We're going to say binding, and we're going to place the name of our command here. So okay, so now everything should work. The wonderful thing about .NET development, or any development efforts, it's a constant cycle of troubleshooting, which gets progressively less exciting past 12 a.m. on any given day. So okay, so we have our button here. If I hit click, you can see that count up is hit. So right now our counter is at 0. If we step through, our counter is at 1, but the UI is not going to update. So we still see 0 here. Let's try this again. Let's click this again. 1, step through, 2. The UI doesn't change, right? So why isn't UI changing? Well, in order for WPF to understand that it needs to refresh and redraw, we have to trigger an event that's called property changed event. So property change is a very specific event that UI is looking out for to know that it has to change something, right? Well, how do we trigger this? So we're going to create another base class. And I'm going to show you sort of the very manual way of doing this. And it's a little verbose. So I'm just going to show this just so that you understand what's actually happening. And then we're going to use a library to just help streamline the implementation, right? So in sample MVVM, we're going to create a new item, and we're going to call it base view model. Base view model. So this is going to be the base class for our view model. And I'm going to inherit from notify property changed. again, just another interface in system component model, right? So it's screaming at us because it wants to implement stuff. Okay, property changed. So here, again, as last time, we don't really care about the event handler itself. So we're just going to say sender e. Yeah, so this is just kind of not else. Okay. This is just kind of a default event handler, right? And then we're going to create a method, which is going to be a public void raise property changed. And we're going to say string property name. So here we're going to say if property changed, property changed. So the handler that we just created isn't null, which I don't quite see how it would be, but it's good to be careful. So we're going to trigger a property changed event, which is an event. And we're going to pass this as the source, and then new property changed event arguments, which as an input take the property name. All right, it's nice and simple, right? We implemented another interface which has a new method, right? So it has an event handler for the property changed event, but also we created our own custom method to manually raise that event whenever we need to. And we're passing the name of the property inside of our event arguments, right? So, okay, so let's go back to our view model over here, and let's inherit from this class. So base view model. Now, this is where things are going to get cumbersome. And this is why I'm going to show you a different way of doing this in a minute. But traditionally, if you're just not using any libraries, you would do something like private int counter. So you're creating a private counterpart to this public property. And then here, you're going to say something like, so get return counter, and then set, this is where things get interesting. So set, we're going to say counter equals value. And then we're going to say this raise property changed and name of this counter. So again, what is happening, right? Whenever we assign to counter, we're going to store the value because we need it. And if we ever get value from the counter, we're going to return this value. But we're also raising the property changed event, again, that the UI needs to understand. It's like, hey, I need to redraw some stuff. And we're passing the name of our property just to notify the UI, hey, this is the property that just updated. So you don't have to redraw everything, just update this, right? So, okay, cool. So let's try this. Let's create a couple of breakpoints. So I'm going to set a breakpoint here, and we have a breakpoint here. And let's also set a breakpoint here. All right, so let's go. Hopefully I didn't forget anything. All right, so let's see if we can iterate some numbers. All right, so first of all, we hit it here because in our constructor, when we're starting our application, we're assigning to the counter. So we're already hitting this, right? So, okay, property changed. Okay, cool. So when I click this, so again, we're bound to the command. So we're running this command. we're adding a new value of 1 to our counter, and we're going to raise property changed, and the property name is counter because we passed it when we called the raise property changed method, and we have an update. So right, I'm going to debug and just disable breakpoints, and yeah, really fun. We have a clicker counter working. Perfect, right? So the issue with this is that you really don't want to do this every time for every property. I mean, this is really painful. What we want to be able to do is just to go back to get set, and when we assign to the counter, we want to just be able to have the UI refresh and call all the events, right? So let's do that. There's a library that we can use called Fody. So what we're going to do is I'm going to come here, and I'm going to delete this raise property changed method because we're not going to need this. And I'm going to right click on the project and go to manage NuGet package. It's going to bring up NuGet sometime this decade. And if we go to browse and search for Fody, so we're going to need Fody itself, and we're also going to need yes, thank you very much. And we're also going to need property changed Fody. Okay, so install the latest. Now, the reason why I was mentioning that you're going to need Visual Studio 2019 for this is because Fody will throw errors if you try to build this on anything earlier than or anything older than Visual Studio 2019. So just buyer be warned. You have a couple options here. Either you can keep using the erase property changed, not ideal, or you can downgrade Fody. I think if you downgrade property changed, no, I think if you downgrade Fody to like 3 point something, it's going to start building again. So just play around with it, or just get Visual Studio 2019. It's great, and the community version is free. So anyway, all right, so we installed this, right? I'm also going to go ahead and install it to the Viewmodels project. Usually you don't have to do this because, no, I didn't mean to set this as a startup project. Usually you don't have to do this because, well, sample MVVM is the dependency of sample Viewmodels, so it should have carry over all the DLLs with it. For some reason, because Fody is doing some weird things with reflection and is kind of trying to do a lot of things under the hood, it doesn't seem to work for me a lot of times if the Viewmodels project also doesn't have it installed. So we're just going to go ahead and install it. So, okay, Fody. And yes, thank you very much. And property changed. Okay. Awesome. All right. So we're all set up here. So back in sample MVVM in our view model, I'm gonna create a decorator called, oh my god, add I notify property changed interface. Okay, and this is using property changed. So in the library that we just installed in the NuGet package, add I notify property changed interface basically handles raising the property changed event, right? So we don't need to, like back in our view model, we don't have to do anything with our counter. Whenever we assign to it, we should see the update. So let's test that out. So we're going to start it up again and see what happens. All right, everything still works. So this is just a convenience thing, right? You don't have to use it, but that makes your life a lot easier by cutting the number of properties and fields that you have to implement by half. So very handy thing. So the last thing that I want to show you with this, and we are going to move on to, I'm just going to show you really quickly how to create a new Rhino plugin. We're not going to go too deep into it. We're kind of limited in time. But the last thing that I want to show you is the binding going the other way. So right now we do some stuff in code behind, not in code behind, in our view model, right? And then that refreshes things on the UI side. So how can we do something on the UI side and then write those properties back, right? So let's do something here. Let's create new public string called my text. I urge you to use a lot more descriptive property names, but since we don't really know what this application is, it's my text anyway. So, and let's, in our view, let's go here and add another thing to our stack. So the button is going to be, now it's going to be in the center. And then we're going to add text box. And we're going to say text binding to my text. And let's give it a margin. All right. So we have a text box. So okay, let's actually go to back to our view model. Where are you? Oh, okay. And I'm gonna set a breakpoint. This is another handy thing. If you right-click on the setter, because usually if you just set a breakpoint here, it's going to set a breakpoint on the getter. But you can actually right-click on the setter and go to breakpoint, insert breakpoint, and it's going to break on the setter. So if you didn't know, now you know. Because I didn't for a long time. So okay, let's run it again and see what happens. So it's building. All right, so now we have our label here. And if I say hello, you see that we're not hitting that breakpoint. That's because I have to switch focus from this UI element for this to actually trigger an update. So I'm going to press this button because there's nothing else for me to do here. So I'm just going to press the click button. Just to be clear, click button has nothing to do with this functionality. It's just another UI element I can interact with here. So if I click on something else, I hit this breakpoint. So right now my text is null. And if I step through, my text is now hello. So we just had an interaction on the UI side, and that got written to our view model. So this way we can actually get inputs from the users and use them inside of our view model to do some stuff. So let's do some stuff. Let's do something fun. So here in the view, I am going to, so I'm going to take this binding to my text. And in our grid, I'm going to say background binding my text. So what does this mean, right? Well, you'll see in a second. And while this is loading, I'm going to go to Chrome, and I'm going to Google HTML colors. So, okay. Let's see. Okay, so Everything is running super slow today. Great. All right. Perfect. Let's see if they have hex colors somewhere. Actually, let's search for hex colors. Great. Okay, so let's pick a color. This is reasonably nice, and we're gonna copy this hex code, plop it in here, and okay, I'm just gonna press the tab to switch to a different UI element. So now we hit the breakpoint, right? So again, we're setting this color to this property, but now the difference is that we're also binding to this property on the as the background color. So now we change the background color of our application. So here I can say, I don't know, 0, 0. Oh, I guess we can't do that. All right, let's pick something else. Let's pick this green. And now it's green, right? So this is a way, again, of taking some input from the user, using it back in your Viewmodel to achieve some sort of a result. So anyway, this is like our very simple click me app, but that shows you how to actually, get started with an MVVM application and how to bind to properties. And again, just for review, right? Just to really drive this idea home. When you look here and you look at how dependencies are structured, so our UI project has a dependency on the view model. The view model only has dependencies on this MVVM base class thing, right? Nothing else. So we can rip this out and put it in some other project and use it. So for instance, it's actually here. Let's add a reference to, actually, sorry. So for instance, in the UI here, in the code behind, I just want to show you something, right? So as we mentioned, for unit tests, for instance, we want to be able to call actual methods on our object, right? So for no reason, this would not be here. I'm just using this because we have this class here. So if I create a new instance, I now have access to all the public methods and all the public properties that we've established. So in my unit test, I can just call VM count up, and I'm basically simulating the button click just with a method call, right? I'm not doing anything crazy. The reason why it's complaining is because we don't have a reference to sample MVVM. So I'm gonna do this here. Again, this is just for the demo purposes, so that's going away. Yeah, so we just called the method on the view model. Anyway, MVVM view models, fun.
I see. Sergey, I think you went through the dependency during the debugging. I just wanted to clarify one thing. So we have a main file in MVVM, and that is calling the UI file. Like, I'm just trying to understand what each file is calling. Like,
Yeah,
we have one view reference, and like, just if you can clarify that.
sure. So let's expand this and let's go through it. So okay, does that clear somehow? Okay, thank you. So okay, we have sample desktop, which again, all it does, this is the thing that's gonna launch your application, right? So all it does is launches your main window. Sample MVVM has our base classes. In theory, everything inside sample.mvvm could be inside sample Viewmodels. I like to decouple them because I might have multiple Viewmodel projects for multiple UI projects, right? If I'm writing some reusable components, I might want to reuse those base classes. So I just like to keep them separate. But in theory, they could be one and the same, right? And then sample Viewmodels is where our business logic lives, right? So this is your application, right? Again, no dependencies on the UI. Here, we know nothing about the UI. Sample.ui, this is our markup. And sample UI has a dependency on the Viewmodels because we need to assign it to the data context somehow. Now, the tutorial that I'm linking to is actually showing you how to, again, do this in a more competent way without actually calling anything from the code behind. It like converts your WPF control into like a generic object in your pass. It's pretty cool, but we're not gonna talk about this here. But yeah, so that's kind of the lay of the land, if that makes sense. Okay, perfect. All right, one last thing. So before we actually go through the Space Monkey, I don't know how much excitement I've managed to build about the Space Monkey, but I hope it's more than zero. So what we're going to do here, I'm just going to show you how to really quickly create a Rhino plugin. We're not going to try to tie those things together. I'm going to show you how to do it in the Space Monkey because we're kind of running out of time a little bit. But if you want to get started with the Rhino plugin, so I'm just going to do it in the same solution. So add new project. And here, let's look for Rhino. And you're not going to find it, and I'm not going to find it. Oh, that's actually handy. So this is something that we have to install. So if you go to extensions, manage extensions, in previous versions of Visual Studio, you go to tools extensions, but they ripped it out into its own separate thing. And if you go to online and then search for Rhino, then you're going to get this handy Rhino common templates for V6. I'm wondering if they're coming out with V7 soon, because Rhino 7 has dropped quite some time ago. Okay, so now we have to restart Visual Studio, so we're gonna do exactly that. Yes, save. So we're going to, okay, I think it's gonna, yeah, so it's installing the software right now. After we close the Visual Studio, I might want to close this as well, just to be safe. Yeah, all right. So I imagine that would take longer than I intended. But it's okay, if it's taking too long. Oh yeah, modify, great, thank you very much. Yeah, then we'll just cancel it and move on with our lives, but hopefully it does all the right things rather quickly.
And the reason we are installing this template because we format our code according to the compliance required by Rhino.
It just makes life very easy for you. McNeil are pretty awesome. I think as a general statement, we can make it. So they have a bunch of code samples on their GitHub page, which I'm also linking to in the description in the README of the Space Monkey. So go check it out. Actually, while this is, oh, okay, sorry, it's asking us to shut down some processes. Okay, so sorry. All right. So if you go to, well, this is installing. So if you go to GitHub, and Space Monkey, So here you'll see on the very bottom, there's troubleshooting and there is the resources section. So again, it talks about, yeah, the MVVM and IOC. This is the tutorial that I mentioned. Check out this guide, it's pretty great. And then McNeil's Rhino plugin sample. So if you go here, they're going to have all the different code samples for view code, for Rhino development, for Grasshopper development, like all sorts of Rhino common things that your heart might desire. And then if we go more specifically here, this is the link to actually setting up like a UI enabled project for Rhino plugin in WPF. So, okay. I didn't expect. Okay, perfect. Modification complete. I was getting nervous. Like, okay. So let's restart. Let's restart our Visual Studio and go back to our sample. What are we doing? Yes, going back to our sample. It's 9 in the morning on the East Coast. So, which I shouldn't complain about because it's like 8 a.m. for you, isn't it?
Yeah.
Yeah.
But I think I had my coffee dose, so it's fine.
Okay. It's an enjoyable company, hopefully. Yeah, definitely it is for me. All right. So let's go back to the sample. And now, if we try to create a new project, when Visual Studio gets its life together, okay. I promise you, when I do development, it's not that slow. I'm blaming Zoom for this. Not now. All right. So if we right-click here and go to Add New Project, so now we'll be able to, once it loads. So now we have this Rhino common plugin for Rhinoceros 6. So that's exciting. If we click here, and you can also search it up here, then our Rhino plugin. So it gives you some options here. So plugin class name, command class name, let's just keep it as is. So I'm going to say finish here. So it's going to wrap things up. And so we have our plugin. So it's a template, right? So the file is set up properly. We have all the dependencies that we have here. Now I'm noticing that these are dependencies to your local Rhino installation. You can also get Rhino common and Grasshopper dependencies through NuGet. We don't have to do it here, but just know that if you need to use it in a console application or something, you can actually go to, I'm just going to show it real quick. You can go to NuGet and you can search for Rhino. Okay. So if you look for Rhino common here, so here you have Rhino common and Grasshopper, and you can pick the version that you want. You have Rhino 7 here as well. In order to run Rhino common, you need a Rhino license. So just beware of that. There's another really cool thing, again, going back to my recurrent point that McNeil are awesome. So if you search for Rhino 3D-MIO, this is their open source version of the objects in Rhino. So you won't be able to run most sophisticated commands in Rhino, like Booleans are not in it. Most of the like hardcore geometric stuff isn't in it, but all the classes are here. All of the components that you would actually use, to build in Rhino Common are here. So this is really, really cool if you're interfacing with like Rhino Compute or Swarm for that matter. And let's not get into what Swarm is. That's a whole other animal. So yeah, just check them out. Just putting it on your radar. They're here. That's a bit of a diversion because we don't really need any of this for the Rhino plugin because it comes with local dependencies. But just keep it in mind. So okay, so we created this new project and it already has some files pre-built for us. So we have the plugin command, and we can change. So English name, our Rhino plugin command doesn't sound very good, so let's just call it our command, which is a marginal improvement if you ask me, but still easier to type. And then our Rhino plugin, yeah, it basically comes pre-built with some stuff, right? So now if we want to actually add it to Rhino, what do we do? So let's first confirm that in the properties and in debug that we have start external program set to your Rhino installation. So we're gonna set this as a startup project and we're gonna run it. So this is going to bring up Rhino. Well, it's gonna build it first and then bring up Rhino. And then we're gonna have to do one thing. I'm just gonna show you how to assign an RHP to your Rhino instance to actually be able to load this plugin. So this will take some finite amount of time. We're just going to cut all this in post, all those dramatic pauses. I imagine no, but that's okay. The silence will be forever on record. 30.
It would be possible, but I need to automate that task.
Just cut out all the silence.
Yeah.
Also speed up the footage by like 25%. All right. So okay. So right now, if we try to, what did we call this? Okay, we call this our command. So if we type our command right now, Rhino will have no idea what it is that we're talking about, right? So what we need to do, and we have to do this only once. So I'm gonna go right-click here and open in File Explorer. And if I go to the bin folder, I see this RHP file here. So I'm gonna drag this and just drop it into the canvas. And so here in the console, we should see some printouts saying loading Rhino, okay, a drag and drop loaded plugin and the path to our plugin. So now if we say our command, now it's here. And the sample came like with some pre-built commands, so it's like a command that draws lines apparently. But here we created a very quick Rhino plugin, right? Now, if you want to get to the level of Space Monkey in terms of UI complexity, then you're gonna have to go to the McNeil code samples or check out the way Space Monkey does it. It doesn't matter, it's referencing the same code sample. And you're gonna introduce a number of other things to your project. Now, you're gonna notice that there are things called Viewmodels and views inside of this package. And this is exactly why we focused on MVVM for like an hour. Not because it's a very good pattern to follow, but also because Rhino and the samples they provide actually encourage you to use MVVM as the framework of choice for the Rhino plugin development, if you're using WPF. So here, if we look at, okay, this is This is the actual project file. I clicked on the wrong thing. All right, so the plugin stays pretty much the same, the way it came with the sample, right? The command gets a little different. So WPF panel command. So here, you can basically copy all of this code, like from the constructor down, all of that. Like you don't really have to change. All it does some management with regards to, like, if you're writing this as a dockable panel, to like let Rhino know that it has to show it or hide it or save the settings so that when you like open your application again, the panel is docked where you left it, things like that. So what you're gonna have to change is you're gonna have to change this GUID. Every Rhino plugin is gonna have to have a different GUID. And also, you're just gonna have to instantiate your, I think this is instantiating the view. Yeah, I think so. Inside this constructor. And then you're kind of good to go. There's some other stuff that you're gonna have to do, but like if you just go through the sample and look at it, you'll figure it out, right? So okay, so let's maybe jump very quick back to the Space Monkey, and you know, we kind of covered like the major things that went into building it. Again, it took like a day to build, so we're not gonna do a code along on this one, but just to kind of take a look at how these concepts that we introduced were actually used there. So I'm gonna close Rhino. Okay. And we're gonna restart our Space Monkey. So actually, before I do this, I'm gonna do something. So material design, which is like another thing we tacked on this conversation, right? This is a styling library, which is an optional thing that you don't really have to use. So in Space Monkey repo, I have this dev working no material design, which is basically just a pure WPF implementation of all of this, right? So I'm gonna switch to that branch. In terms of functionality, they're up to date with each other. And I think I closed the wrong Visual Studio, but that's okay. So I'm just going to, like, the interface is gonna look a hell of a lot uglier when we open it up, but that'll make things a little clearer, hopefully. So, okay, so let's go to Space Monkey. And we're just gonna take a look at what are the components that we're using here. And you're gonna recognize a lot of those things. So, okay, almost there. All right. So again, we have Space Monkey Rhinoceros, right? So this is the Rhino plugin that actually adds it to Rhino and does all the UI management stuff just to like put our view and our view model into that panel, right? So that's what we created with this extension that we installed. Now, Space Monkey UI and Space Monkey Viewmodels, that's familiar. We have our main view here, and you'll see that there's the main view and there are other controls, right? So you know how we show a bunch of cards when we pull the satellites down, right? So each of those cards has its own view. And again, because I didn't bother setting up design view models, all of those views just look broken when you look at them in the designer. It's like, yeah, I don't know what's going on. But I'm mostly just paying attention to the XAML anyway. So that's all of our views and components. We have corresponding view models. So if you go to view models, you'll have kind of a mirrored structure. So satellite card view model is responsible for the satellite card. And then our main Space Monkey core view model is responsible for Space Monkey main view here. One important thing to note, again, because this is a simplification to just kind of get you guys acclimated with the idea of MVVM, right? Some people would argue that view models should also be separated into view models and data models. The idea being that data model contains all the business logic of your application, and then the view model becomes the layer in between your data model and your view, which only handles business logic pertaining to the drawing things to the UI, right? Just be aware of that. I don't find it necessary a lot of times. That seems like a bit of a complication. So usually for projects like this, I just use a view and a view model, and I just do everything in the view model. But again, there's a school of thought that suggests that you should separate those as well. So, okay. So UI components, view models, MVVM, the same base classes we wrote. There's some helpers here, but we don't have to get into that. SpaceMonkey IO. So this is useful because there are certain classes that don't really have any dependencies, right? So for instance, schemas, right? They're just data transfer objects, essentially DTOs, right? So for instance, when we're calling into the API, we're getting a JSON back, and we have to deserialize this JSON into a C# object. So we're just storing those objects here. They don't have any dependencies on anything, and it's also might be useful to share them between different components of the application. So I like to just create like an IO project and just throw all of this IO stuff here. Same with event arguments, right? So the way we're baking here is by triggering an event that we're subscribing to, and it's just nice to have access to the IO portion, the input-output portion from anywhere in the application, right? Because it's important to like keep track of what dependencies you add to what projects. Ideally, you want to have the absolute bare minimum of necessary dependencies on other things that you need to run a particular project, right? Because then if you start to, like if you want to take it out to use somewhere else, you have to bring all those dependencies with it, and sometimes it just creates problems, right? So keep things to a minimum. And then we have, so the new things here, right, aside from, like this was basically our sample desktop, UI, view models, MVVM-based classes. The new things are IO, optional, don't have to do this, I like to do this. And then the SpaceMonkey web client, which basically a component that does all the talking with the REST API, right? So if we look at the web client, so we have this API key. When we're instantiating the SpaceMonkey web client, we're passing the API key to it. The API key lives in the secrets.json file. I have instructions on how to get it. It's a free API key. You just have to register on that website, and they're going to give you a key. And I think it's limited to like 1,000 calls an hour or something. Good luck hitting that threshold unless you're doing something crazy in Grasshopper. So yeah, you'd be good. So okay, so we're storing our API key. We have our server kind of hard-coded here. Ideally, you would have some sort of a config file that you would be reading from in case you want to swap out the endpoint. We're not swapping the endpoint, so it's just going to stay here. So that's hard-coded. And then we have a method to get a URL. We're just calling one route, the above route on this that API. So we are combining the server, and then it's a GET request. So normally, and I'm kind of wondering why they did this. Normally, when you have so many parameters, you would make it as a POST request, right? So a POST request essentially has a POST body, right? And then you can pass a JSON, post it to a route, and get a response back. So they did this differently. They just chain together a bunch of parameters for their GET requests, well, that was their choice. So that's what we have to do. And then we have the HTTP client, which is just kind of a C# HTTP client for making HTTP calls, right? So here, all we're doing is we're making a new asynchronous method saying get above satellites. We're passing latitude, longitude, altitude, like all the things that we've been entering in the settings portion of the UI, and then generating the URL, and then just making a get call, awaiting the get call to return. If you don't put a wait here, it's just going to make the call, and then the return is going to return on like a different thread, so you won't be able to catch it, right? You read it, and then we deserialize this as one of our data transfer objects. So it gives us some info and a list of satellites here, right? Very simple. So yeah, I mean, this is really it in terms of like how SpaceMonkey differs from, there's just more logic in the view model. Like if you look at the main view model, there's just more stuff here, right? One important thing to note, if you want to bind to like an enumerable, like a list, to be able to update things in the list, you want to make it an observable collection, because an observable collection knows to emit proper events, like a collection changed event, I think, whenever it's updated. So the UI, same as with the property changed event, it's going to know that, oh, something changed, I need to redraw, right? And then you're just passing view model. So this is kind of the nesting that I was mentioning before, right? So you're passing these models here. So yeah.
Sergey?
Yeah.
Like, are you storing all those coordinates? Like every time you're making the call, you're storing that JSON data, and you have the points, and then using Rhino command, you just bake it. Like, and every
Yes.
time, how's the data updated?
So when we get our satellites, there are two things, right? We have two types of objects. Like SM satellite, SM for SpaceMonkey, is just the data transfer object. So this is what we deserialized our JSON to. So when we make a call to the route, we're just putting all satellites here. Now that's not going to get rendered to the interface, because we need to turn them into view models to actually be able to get instantiated, right? But what we're doing is we're selectively dumping in chunks, right? So show satellites, num sats, we're loading 15 at a time. Basically, when you scroll down, there is a little hack with encode behind. Like I said, that usually wouldn't do this, but again, this is fine because it's just a small UI thing, right? So if you look at main, at the code behind, there is actually an event handler for the scroll viewer. Each time it hits the bottom, it gets the view model from the data context and then calls the show satellite method. So it loads 15 more satellites to the view. Otherwise, rendering 1,000 satellites at once, we will be here forever, right? So this is something called pagination, basically. Before I introduced pagination, it literally took like 20 to 40 minutes to refresh the UI. And now it's pretty much instantaneous, right? So that's with regards to that, right? And then in order to actually show them, right? So when I say load, we're basically converting SM satellites. We're converting them to the satellite card view model and putting them to the observable collection. And the view on the view side, so that's actually not a good thing to show. So here in our view, if we look at inputs, okay, scroll viewer, items control. So item source is bound to our observable collection called display satellites. So this is where the view models for those cards live. Now, how do you convert view models to UI elements? So you do it through the data template. So essentially, you can specify data type. When you see a satellite view model, make it a satellite card. So the UI knows that in this observable collection that we're binding to, when you come across an object of type satellite card view model, you should render it as a satellite card, which we defined in controls here. And the cool thing is that this automatically puts this instance of satellite card view model as data context for the satellite card. So the satellite card doesn't exist within the same data context as the main page, right? It has its own sort of local data context by its own view model. And since we populated all the properties that came from the API, we can actually render the satellite information here. So maybe let's, so I'm gonna rebuild this. And I'm just gonna show you exactly what I'm talking about. And then the very last thing that I'm gonna show is the material design portion. That's gonna take a few seconds, but it's just a nice little cherry on top. If you want to make things look pretty, which is a must always.
That's where the architecture side of you comes in, aesthetic wise.
Yeah, that would make a lot of my professors very angry, my former professors. That's a whole other topic. But all right. So are we okay? So we rebuild this and let's run this. Okay. Right. So hopefully that branch still works. I've built the other branch last night and it worked. I did not test this one. So well, we're living on the edge here. Let's see how that pans out.
I like the risk you are taking.
Yeah, exactly. We're doing something crazy here. All right. Let's see. So I just saw Space Monkey blipping here, which is a good sign. All right. And all right, so here's our, so you can see that it looks quite a bit different from what I showed you in the beginning. This is because we ripped out all the styling. So this is just default WPF. But this is just to show that material design, which is like a styling library, has nothing to do with the functionality of your application. You can still build MVVM applications, obviously, without any styling. So okay, let's switch to shaded. And so here we can search for all the different kinds of satellites. Let's search for military ones just because it's fun. So I'm gonna, also, it's funny that I have to say this. This is legal. This is public domain information. We're not spying on military satellites, which would be awesome, but yeah, we're nowhere near that level of expertise. So okay, latitude. Let's just pick something. Longitude, and again, because the bindings are two-way, you can actually enter a number here. Well, let's make it a little more drastic, and this will move the slider because they're all both bound to the same property. So okay, military satellites at these coordinates, search. So now again, we populated, like each of those cards is the separate control that we've seen, right? So here we've got satellite ID. Am I not showing a name here? Oh no, here, Midas. All right. So we can, oh, Cosmos, this is a Russian military satellite. Fun. All right, so we can bake them individually. So we can just say bake, and we got our home planet and a satellite over here. Or we can, I'm just going to delete that, we can bake them all at once. So here are all the military satellites in a 90-degree dome above this point on Earth's surface. And once again, we have all the metadata in there, right? So there's another Russian military satellite here. Cool. A sentence that I always wanted to say on a live stream. Anyway.
So
yeah.
Just so that metadata, is it only accessible through the plugin part, or if I want to access it in Rhino, like how let's say, how do you access it right now?
So this is in Rhino. So we just go to the properties tab, and so for Rhino objects, the properties tab, if you didn't put anything there, it's going to be empty. You can actually, so I'm highlighting Earth right now. We can actually create a new entry and say, I don't know, name Earth, right? So this is just a handy way of adding metadata to Rhino objects. The cool thing about this is that you can read this in Grasshopper. So you can take objects from the scene and then load the data back in. And Andrew Human has, like the Human plugin, has ways of reading those attributes and so forth. So that's really handy. And yeah, so this is what we're doing here. And the way we're doing this, so let's look at this in the code. So if we go to Space Monkey Rhinoceros, actually, yeah. So I think it's in the command. I'm gonna have to find this because, yes, it is. So normally, again, I'm being a little lazy here. Normally, you would create a separate command to bake stuff, right? You have one command that brings up your UI. You have another command, like a hidden command, that bakes stuff. The reason why you want to do this is because you can then roll back your changes. So if you Control-Z in Rhino, it will know how to unbake the stuff you just baked, right? We're not doing this here. We're basically on our Space Monkey core view model. We're creating an event, bake triggered, and then we're assigning an event handler inside of our Space Monkey panel host. And this is where we're doing all the work, right? So we're getting, so we have this bake method that accepts a list of satellite DTOs, right? These are not the view models. You don't want to be passing view models around because they tend to be heavier, right? And this is another reason why we have this IO project. So the SM satellite is accessible to Space Monkey web client so that it can get stuff from the API and deserialize it into something it can understand. It's accessible to the Space Monkey view model, which basically converts it to the view model and uses it in the UI. And it's also accessible to Space Monkey Rhinoceros because that's where we have the methods for actually baking stuff to the scene, right? And so here we're doing some conversions. So like sat to point just takes the satellite and takes the like longitude, latitude, altitude, and just figures out in Rhino space where that is, right? And I hope my math is right. It looks right, so we'll just go with that. Scales all the stuff. And then to bake to Rhino, essentially what you're doing is you are getting the object table. So Rhino doc, active doc, objects gives you back the object table. And the object table has methods for adding stuff to the object table. So OT add sphere takes a sphere that we create here, right? This is Earth's radius at the equator. And then this point, again, the way we add attributes, we get the point, we create an instance of object attributes class. And then for every property on the SM satellite object, we're just looping through, and we say set user string, and we give it a name, and then give it the value from that object. And so that's how the metadata gets written to the attributes. And then when you call add point or add any other kind of geometry on the Rhino object table, you can actually pass attributes with it, and that's going to get written to the object. So yeah, that's really it from the standpoint of like making things work, right? The very last thing that I want to just briefly talk about in terms of styling, right, is something called material design. So material design library was originally developed for the web, and I believe it was developed by Google. Somebody please fact check me on that. But there is this wonderful person that I'm going to pull up right now. Trying to go back to Space Monkey. All right. Okay. So again, if you go to resources down here, so WPF material design is essentially a version of the material design graphic standards and graphic library, borrowed from JavaScript and written in C# as a WPF style, right? So they have their own project website. So let's see, material design in XAML. So you can see, like, it just gives you a much nicer looking buttons and UI elements and some other stuff that the default WPF library might not have. It gives you pack icon components, which are neat because these are just little SVG icons basically that you can use, right? So all this good stuff. And then there's a GitHub page. You don't have to clone this from GitHub. So James Bullock, aka Butcher's Boy, yeah, here we go. So he basically started and created this project. So if you want to take a look at like what's inside those XAML markups, feel free to check out this repo. And also it's available via NPM, via NuGet. Getting my package managers confused. So for instance, here in the UI, if we right click and we go to, actually I have to switch branches. So now we're going to go to our main branch. Okay. Yes, reload all. So again, for some reason, the same way as Fody seems to fail if some other projects don't have it. I had problems with material design when you don't add it to like the main project that's running it. But you know, for the purposes of this exercise, let's just say that in your UI project, you would look for material design colors and material design themes. So that just pulls down and installs the material design library. And now, in order to actually use them, so in your view, you're going to go here. And so you're going to reference material design via this URL. And by the way, they have explanations of like getting started and all this stuff, right? So you can check that out. So you reference this as a namespace in your XAML. And then what I like to do is I like to create a resource dictionary, which is essentially a way of getting all of your styling dependencies and styling things into one XAML that you can just reference through from multiple components. So if we go here into our resource dictionary, then we're going to see a couple things. So first of all, these are the things that I defined myself, right? So this is very convenient when you want to create like a solid color brush, for instance, and give it a color and be able to reuse it. So what this allows you to do is, in case you want to change that color later, you're not doing search and replace through every time you used it in your markup and like replacing this color with something else. But instead you can just change this color here. And since you've been using this brush throughout your project, it just automatically updates. So that's a nice little workflow improvement, right? So to just quickly show you how that works, if I go back to main.xaml, not CS, here we go. So here I can say like label foreground static resource, and then what is primary, let's see how we called it. Primary hue dark foreground brush, which should come up here. I'm not sure why it's being stubborn. Yeah. So usually if you primary resource foreground brush, we might have to, either I'm forgetting something, or we might have to restart Visual Studio because the WPF designer can be funky. But that's the main idea. So you can use static resources that you define in your resource dictionary. Maybe we just need to build this. Let's try to build this. Unless it gives us an error. And then we're not gonna try to fix it live. I'm just gonna leave it be. So let's see. Okay, rebuild all succeeded. So yeah, this is just WPF being yeah, just complaining. So anyway, but normally if you rebuild everything, you will have a IntelliSense and you would be able to pick one of the resources, one of the brushes that you've defined before. So for instance, here I'm doing exactly that. So like later in the code, in the pack icon, and that's how you add the pack icon, the SVG icon. I'm just using one of the brushes. So that's one useful thing, right? And then the other useful thing for resource dictionary is if you import different material design XAML files, right, you will actually automatically update the styling on your components. So each of those, they're kind of like templates. They point to specific WPF controls. And when they find this control, they restyle it, essentially. So this is a very easy way to just make everything look different. And you can pick from different themes. Like, again, look through the GitHub repo. They have documentation, like look what themes are out there. And yeah, this is really it. Like, you add this to your resource dictionary, you link to your resource dictionary from all your controls, you have stuff that looks different. So that's really it. I don't have anything else to offer, but
that's a lot to absorb.
Yes.
So I'm gonna watch it two or three times just to ensure I understood all the parts well.
Do we have any questions? I think somebody was there's something in the chat.
Yeah. I know you spent like a whole Saturday last week, and to package it in 2 hours was a challenge, and I could feel it that okay, there are lots of important concepts going on, and I need to restudy this. So it's a lot of amazing work you put out in just a short amount of time.
Thank you. But yeah, just think about this. Like, if you guys are feeling overwhelmed by all of this, just think of this as like an exposure to just some important concepts that are important to look into, right? So again, MVVM, Google it, study it, watch the tutorial. It will make things a lot easier for you when you try to build scalable applications. That's one thing. IOC, we haven't covered it here, and thank God that we didn't. but that's another very important concept. The tutorial that I linked to covers it. again, it's not my tutorial, it's just some guy I found on YouTube, which I thought was really great. So watch that. Styling in material design WPF, not necessary, but it's nice to make things look pretty. So if you're interested in that sort of thing, also it doesn't have to be used with MVVM. You can write your own like good old WPF application with a bunch of stuff and code behind and still use material design, and it will change the look of it. And then, yeah, and then like REST API, you know, it's funny because a lot of the things, a lot of the people who, you know, are in architecture or in AAC, and they kind of have interest in computational design or programming, but they don't necessarily have either the time or just, I mean, usually either the time or the desire to like really invest into studying those subjects. They say something like, oh yeah, you know, I'm an architect, but like I call into APIs from time to time. So, you know, also this project would be useful for people of that nature because you could just use the client and the setup for the client inside a Grasshopper component or like a C# component in Grasshopper, right? Or your console application, whatever you want to do with it. So yeah, if you find this useful, dig through the Space Monkey. It's open source. If you want to do something with it, like create a pull request, I'll review it. If you want to add some functionality, that'd be cool to keep that going. But yeah.
I'm gonna experiment with Space Monkey. Like recently, I'm working on a IoT dashboard, and I was like for that I was looking into API asynchronous programming. So a lot of concepts. This is how you are implementing it.
Yeah.
So since we reached the 2 hour mark, and there are like a few questions I had, but I will limit my questions to 2. So like I think a lot of people who are watching this or listening this are uh, computational designers who are interested in software development and passionate about AEC tech in general. So from your journey, like what are some things you recommend or advise us?
Yeah, I mean, the one advice I can give is just tinker with stuff. Like, I mean, in terms of my personal journey, right? Like, I started coding. I first went to University of Toronto before I went to Pratt, so I studied there for 2 years, and we had to take a bunch of electives, you know, in all the different disciplines not related to our major. And I decided to pick up like a Python class. So it was literally one semester Python fundamentals, like how to assign stuff to a variable, right? That was really useful because once I knew kind of the basics of coding, then it was easy to just tinker with stuff on my own. And then turns out that, you know, I come to Pratt and we are using this new software for me that I haven't heard of before called Rhino. And oh, wow, Rhino has a Python API. So I can actually do stuff with Rhino objects in Python, which is a language that I sort of kind of know, right? So that was the beginning of that. And then I kind of proceeded with you know, having an interest in computational design and just learning these new methods and techniques. Like you only learn by doing. There's no magic to coding. It was always funny to me when I would like tinker with something in studio and people pass by and they just see like a command line terminal pulled up, you know, on my machine. They're like, "Oh my God, are you coding?" I'm like, "Yeah, no, I just like deleted the directory in the terminal. Like, I didn't do anything crazy, right?" So there is this weird aura of mysticism around coding. I think we have Hollywood to blame for this. Like, no, you just do stuff and things work, and then things break, and you go on Stack Overflow and figure stuff out. So definitely tinker. That's one advice. And you know, once you know one language, it becomes a lot easier to know other languages. Like I think Python is a really good starter language because it's looser and it's a lot more forgiving in a way. You don't have to get into like, you can get really deep into Python, but you don't have to. And then, you know, C# is my new love, because it's a type strict language, and there's a lot of really cool stuff that you can do with it. It's very structured, which is very nice. So yeah,
I see.
it's my
And
first.
yeah, even I can totally relate it. Like, I think once you start a language, doing some of your passion projects where you implement, you get stuck, then you do Googling and then you build your project, because there are a lot of things in a particular language to learn and you can't just
Yeah.
stop learning. So it's at a point you need to stop and just implement.
Yeah, exactly. Like it might be intimidating to start, but like you can download Python and as the Python interpreter and create a new file and like print a hello world. Just start there, right? And then as you go along, figure out the things that you want to do, and then Google around just to figure out, you know, how to do them, and then you'll gradually build up sort of you know, the vocabulary that you need to do the things that you want to do. That's kind of how I learned C#. Like I didn't know C# before I joined Core, and that was a very sink or swim approach. Like I don't know if you had Emil on your channel or not. Maybe, I don't know. This is a next guest suggestion. But yeah, no, so Emil was also from Core, Emil Paulson, just, you know, my wonderful colleague and friend. He was unfortunate enough to sit right next to me when I just joined Core, and he was like a C#, was and is a C# expert. So I learned C# literally by having a C# project assigned to me to complete, and then bugging Emil every 10 seconds, saying like, hey, this doesn't build and this doesn't work, and I don't know what Visual Studio is doing right now. And then I bugged him less and less. So yeah.
So it's good to have like a buddy or a partner in case you get stuck and that they are helping. Yeah.
If you know someone who can code, feel free to make their life miserable by asking them a lot of questions. I don't know if that's just me, but like I like teaching stuff to other people. I don't know if everybody is the same, but if you find somebody who A, knows how to code and B, likes teaching, just cling on to them and get everything that you can out of them. If that's not an option, you don't know anybody, again, don't be discouraged, just tinker with stuff. Like for years, I didn't really have anybody. This sounds really depressing. I didn't have anybody to talk to. I didn't have anybody to talk to about those computational issues necessarily, right? So that was just in studio trying to hack some stuff together the night before a midterm review, you know? So yeah, it's gonna be a painful but a very rewarding journey with a lot of iterations and a lot of frustrations and things not working for obscure reasons. But yeah, just Google away. There are a lot of resources out there. Stack Overflow, make a Stack Overflow account, ask your own questions. People will politely or not always politely explain to you how your ways are wrong. So yeah.
I see. Sergey, you said something you should not, like, now I'm gonna bug you after 3 months to do another session because you like teaching. But anyways,
Yeah,
my
yeah.
last my last question is, okay, we know the environment about architecture studio and computational group, how they work, but like how does working in core studio look like? Like people, culture, the way you guys work, because you guys have been developing such amazing tools. So just want to know how is the culture there?
No, I mean it's wonderful. I think part of why Core Studio has been very effective, you know, over the entire duration of its existence is because it's pretty horizontal in terms of structure. So, you know, Rob Otani, for instance, you had him on the channel, right? He's the CTO of Thornton Tomasetti. He's also kind of the head of Core Studio. but there's not a lot of layers between developers and Rob, for instance. Like we talk to Rob, right? So it's easy to, despite the fact that there's like a huge gap in terms of, you know, your place in the hierarchy in the company, there's a very direct line of communication. So that makes things a lot simpler. Also, before the pandemic, you know, when we're all working in the same office, and to the degree to which we managed to recreate it after the pandemic has started, you know, we talk to each other. Like you kind of develop a sense, because it's a small enough group. Like we're about 20, 22 people strong, right? It's a large enough group to have enough resources and enough different branches of knowledge to have an effective team, but it's also small enough for everybody to know whom to ask if the questions arise, right? So I know that like if I run into some crazy gnarliness with Visual Studio or IOC or whatever, I'm gonna ping a mail. If you know, we have Liddy, like an AWS specialist, so she does a lot of DevOps and stuff. So if I have those types of questions, I go to her. Yeah, so it's just kind of being very horizontally integrated. I think been very helpful, and the fact that again we all like to talk to each other. So that would be my take.
Yeah. So like, are you guys planning to do like hybrid or in person once everything gets back to normal? Because it looks like it's a bit more productive than virtual. I don't know.
Yeah, that's a good question. We're not currently being pushed to go back. I mean, we kind of, you know, the TT has been very gentle with regards to where people want to work. And we kind of figured out over the past year that we can be just as effective at home as in the office. I've been going to our new office twice a week, just because I love to ride my board. I stopped using the subway, so it's like a nice half an hour ride over the bridge for me. So that's part of the reason. Also, like having a reason to shave and put on a good shirt, like twice a week, get out of sweatpants, like that's nice. Even though, you know, for the past couple months, it's practically been just me and the construction crew because we just moved to a new office. But yeah, so I'll be there. We'll see how people return, but yeah, I think all in all we figured out a pretty successful strategy for working remotely.
Awesome. So now I think I'm very glad that like the people who stayed throughout, it's like more than 2 hours and it's a lot of learning, and thanks a lot. I want to make a small announcement. So if I can share my screen, Sergey.
Mm-hmm. Oh yeah, sorry.
Thank you. So next week, we are doing a session with Karthik on generative algorithms, and from art to architecture to urban spaces. So the timing I'll share soon, but that is one thing we are doing next week. And I want to thank Sergey for his time and this amazing sessions. Thanks a lot, Sergey.
Thanks for bringing me along, and it's always a pleasure to hang out. So thank you.
All right. Thank you everyone for joining the session. If you have any questions, I will, if possible, I'll ask Sergey about it and convey to him and get back to you. All right. Thank you. Bye-bye.
Cheers.